definition of a geometric series is there's some number that is raised to the counter. So, example, some 1/3 to the n, which is actually doesn't look like a geometric series the way it's written, but if I rewrite it like this, which is the same thing because 1 to the n is 1, that's a geometric series.
The whole number has to be raised to that power.
The whole number has to be raised to the power.
And that's why that one's not.
Well, that's not, notice, the power in a geometric series must be the counter, Andrea. This power isn't the counter, the base is the counter.
Oh, the power is what's, okay.
Right. So there's two things to look for to make sure the difference between the p-series. The sum of 1 over n squared, sum of 1 over 2 to the n. GO, p-series. What's raised to the power is what matters here.
Okay.
Good? Okay. So 1, it's not a geometric series. Now, we haven't spent much time talking about this. I've just said it intuitively many, many times. If the terms do not go to 0, the thing can't add up to something finite. Because if every... So theorem, if the limit as n goes to infinity of the a sub n does not equal to 0, then the sum from n equals 1 to infinity of the a sub n's diverges. The terms have to go to 0 in order to get convergence. Because if they don't, suppose they make it down to a fourth. Well, what's a fourth plus a fourth plus a fourth infinitely many times? Infinity, right? It gets bigger and bigger and bigger and bigger. It does not converge. So this is the easiest test there is. That's the easiest test. Okay, so here's where we are. 1, it's not a geometric series. 2, the limit of the terms do go to 0, so this test doesn't help me, right? This test says if the terms don't go to 0, it diverges. But the terms do go to 0, so this test doesn't help. No help. Since the limit as n goes to infinity of the a sub n does equal to 0. Which is what... No, he didn't. They also have positive. Okay. So I've checked one thing. I've checked a second thing. 3, is it a p-series? Not a p-series. P-series says it's got to be 1 over n to the p.
Why isn't it? Because the plus 2?
Because of the plus 2. If that weren't there, it'd be a p-series, we'd be done. I would say, Mark proved the p-series test. He said it converges as long as p is bigger than 1. P is 3. This guy converges. I'd be done if it weren't for that plus 2. Okay? Everybody with me so far? Questions, any of what I've done so far? This is the process you're going to go through on every series. On every series, you're going to say, is there a mosquito in the series? Then, if there isn't, you're going to say, if there is, you're going to kill it. If there isn't, you're going to say, do the terms go to 0? Because if the terms don't go to 0, I'm finished. But the terms do go to 0, so that was no help. Then you're going to say, is it geometric? Can I just knock it out in 30 seconds? It's not. Then you can say, is it a p-series? Because that's an easy test. But it's not a p-series. Okay, so none of the stuff we know so far works. Okay, so now we're going to go, the next test you're going to go after is the direct comparison test. So 4, direct comparison test. The direct comparison test says something that is really common sense. Doesn't matter where they start. Now, we're only talking about series so far with positive terms. I don't know if you've noticed that, but we haven't ever had any negative a sub n's, right? It gets harder when they get negative. But right now we're only working with positive terms. Now, so if I have a series and it's less than some other series that converges, I'm tired of writing converges, it's going to be C's from now on. Then the first one's got to converge. Why? Because this one converges, it's a number, right? Well, if this one's positive and it's smaller than this and we're adding up positive terms, it's getting bigger and bigger and bigger, but it doesn't get bigger than this number. So it's
bounded by that one. Whenever that one converges.
right. It's bounded by this one. That's exactly what we would say, Andrew. It's bounded by this one. This one converges, so this one has to converge. Now, there's always confusion about this. What if this was bigger than this one and this one converged? Does that tell me anything? No. That's like me saying I have more money than Andrea does. She says she's got $10,072 in her account. How much money do I have? You got no idea. I could be infinitely wealthy. I could be a Martian and own all the money on this planet and all the other planets. Right? You have no idea how much money I have. It's just greater than the amount she has. That's useless information. Okay. So, the direct comparison test says if I can get this one smaller than one that I know converges, I'm done. That's what he just did. He said 1. The direct comparison test says check to see if the terms are bigger than 0. So a sub n is greater than 0 for n equals 1, 2, dot, dot, dot. Right? The terms are positive. 2, these terms are less. 1 over n cubed plus 2 is less than this. He did the math here to show that. Well, if every term is smaller...
Wait, what did he do with B?
He showed that this was true. That every term of this series is less than every term of the series that's the P series 1 over n cubed. Put 1 into here, what do you get? You get 1/3. Right?
Yeah.
Is that less than 1 over 1? Yep, 1/3 is less than 1. Put 2 in here, what do you get? 1/10 is less than 1/8. Yep.
But how did the 1 over n cubed get to the other side?
No. Here's why. Let me finish what I'm doing here, Andrew, and we'll go backwards. What he's trying to show, this series we know converges, right? So he picked a series. Well, he didn't pick it, I gave it to him. But I gave him a series which we know converges, that we could show this series was smaller than. Now on the test, you'll have to figure out what the series is to compare it to. But the point is, this series is less than this series. We know this series converges, but we have to prove, once we pick a series that we want to compare it to, it's up to us to prove to the rest of the class that every term of this series is less than every term of this series. Because if they're not, I can't put this less than sign here. Okay, so now this is less than that. This one converges, so now I can say the sum from n equals 1 to infinity of 1 over n cubed plus 2 is less than a P series that we know converges, right? So this series also converges. They call it the direct comparison test for a reason. You find a series that you can compare it to. You get that this series is less than this series. You know this series converges, you're done.
I see where you put it for notes. So you can put it.
Right, yeah, this is, yeah. I told him what series I wanted to compare him to. I won't in the future, but suppose I gave you this series. Well, that's not a good. It's not really a good one either.
Oh, Ted making up stuff.
Yeah. The problem with calculus is you can make up problems that I can't work. This series is less than this series, right? The denominator of this is bigger than that. That's a geometric series. That one converges. I know this one converges. This one's always positive. The terms are always positive. Every term of this series is less than every term of that series. That's a geometric series. I not only know this one converges, I know what it's equal to. Let's start at 0. And then I know this one's 1 over 1 minus 1/7, which converges. Okay, questions? Yeah.
All right, when you compare the two series, do they have to look like sort of alike, or you can pick any series you want to?
As long as you can do the algebra like you did here, the fact that they look the same made this algebra easy because you subtracted an n cubed from both sides, right? As long as you choose a series that you can show this one's less than that, they do not have to look the same. But you do have to be able to show that every term of your series is less than every term of the series that converges. Other questions?
Why did you pick the 1 over 1 minus 1/7?
Because that's the formula that you have memorized for the geometric series. It says that the sum from n equals 0 to infinity of r to the n is 1 over 1 minus r if 0 is less than r is less than 1. And you've memorized that. Okay, Miss Chelsea?